Okay, let's get right into it. Today's explainer is all about the 2023 National Electrical Code, specifically diving into the foundational updates in Chapter 1. Now, Chapter 1 is basically the rulebook's rulebook. It establishes the core principles for literally every electrical installation out there. It's split into two main parts, Article 110 for general requirements and Article 100. And wow, did they overhaul Article 100 this cycle? They completely consolidated all the definitions. I know, an administrative update sounds a bit dry, but this is actually a massive shift. It completely changes how we read and apply the codebook out in the field.
Think about a typical day on the job site. Say you have to temporarily shift a plumbing pipe just to reach an electrical wire. Can you still legally call that wire accessible? Or what if a panel board is locked? If you need a key to open it, does that key suddenly count as a tool? Well, let's dive into this, because as we're going to see, rigid semantics absolutely matter in electrical safety. One tiny misunderstood word that can literally be the difference between a fully compliant installation and a really dangerous code violation.
So, back to that locked panel board scenario. The code makes a super important distinction between something being just accessible versus readily accessible. If a piece of equipment is only accessible, you might need to whip out a tool, like a screwdriver to pop off a junction box cover. But readily accessible, that means you can get to it fast. No moving obstacles, no dragging out portable ladders, and definitely no tools. But here's the kicker, and it's a crucial clarification. A key is not considered a tool in this specific context. So those circuit breakers locked safely inside a panel board, they still perfectly meet the definition of readily accessible.
To break all this down, we're going to follow a pretty straightforward roadmap today. First, we'll cover the foundation of safety. Then, we'll look at access and clearances, followed by modern power management. After that, we'll hit grounding and protection, and finally wrap up with everyday environments.
Let's kick things off with Section 1, the foundation of safety, consolidating the code. Honestly, the biggest structural change in the 2023 NEC is organizational. If you look at older editions, definitions were just scattered everywhere, tucked into individual articles. It was kind of a mess, right? Well, the new NEC Style Manual changes all that. It mandates that every single definition must live right in Article 100, perfectly organized alphabetically. It was a huge undertaking, but it ensures total consistency for everyone working in the trade. No more frantically flipping through chapters trying to find what a specific term means for a specific application. The whole shebang is just in Article 100 now. All right, let's run through a quick sequence of these foundational definitions to see what's changed. We'll start right at the physical limits. Ampacity. This is the maximum current, measured in amperes, that a conductor can carry continuously. And the key here is doing that without getting so hot that it exceeds its temperature rating and, melts the insulation. Next up is appliance. Now, this definition draws a really clear line in the sand. An appliance is utilization equipment built in standardized sizes. Think of a kitchen stove or your typical window AC unit. It specifically separates your everyday household or commercial equipment from, say, complex, custom-built industrial gear. Then we have the AHJ, or the authority having jurisdiction. You absolutely need to know this one, because these are the folks actually enforcing these precise definitions out in the real world. Whether you're dealing with a local inspector, a fire marshal, or even an insurance rep, the AHJ always gets the final say on whether your installation is up to code. Okay, let's follow the flow of power for a second. A branch circuit is essentially the final leg of the electrical journey. By definition, it's the conductors located between the final overcurrent device, so like that last circuit breaker sitting in your panel, and the actual outlets where the power is finally consumed. And building right off that idea, if the branch circuit is the final leg, then the feeder is basically the middleman. A feeder is made up of the conductors between the service equipment, where the power actually enters the building, and that final branch circuit overcurrent device we were just talking about. See how it works? The code is just meticulously charting out the entire hierarchy of power distribution.
Moving on to Section 2, Access and Clearances, Navigating the Job Site.
Now, the code makes a really sharp distinction between the word accessible when we're talking about equipment versus when we're talking about wiring methods. And the 2023 update adds a major clarification here. It states that if wiring is blocked or made inaccessible by building piping, ductwork, or other mechanical systems, it is strictly not considered accessible anymore. I mean, it makes sense, right? You can't just assume some poor guy down the line is going to disassemble a building's plumbing just to reach an electrical junction box. This update prevents some totally impossible and frankly dangerous maintenance scenarios. All right, on to Section 3, Modern Power Management, New Tech, New Terms. So here we have a brand new definition created by a specialized task group, the Energy Management System, or EMS. Now, this isn't just a single box on a wall, it's an entire system defined by its specific components. We're talking monitors, controllers, timers, and the communications equipment linking them together. And these systems, they are exploding in popularity right now. They're what allow modern buildings to safely supplement the traditional grid with renewables like solar or wind, all without accidentally overloading the existing infrastructure. And this brilliantly illustrates why getting these definitions right is so vital today. What we're looking at here is a commercial battery energy storage system. To operate this safely and legally, it relies heavily on the code's exact definition of load management, which is a function performed by a listed EMS to control electrical loads. These smart systems can actually shed optional loads when power supply gets tight. That means you could potentially upgrade a facility's power capabilities without having to rip out and replace the entire physical electrical service. It's a real game changer. Okay, here's where things get genuinely futuristic. Let's talk about the Class 4 circuit. People often call this digital electricity or packet energy transfer. It's a fault-managed power system that literally uses software to verify the presence and correct operation of devices before it even lets power flow. If the software detects a fault, boom, it terminates the output power instantly. But because this level of protection relies entirely on software and listed equipment, rather than an electrician physically turning a wrench, it needed a completely new set of definitions, plus a whole new article in the codebook, to ensure it's deployed safely.
Let's switch gears to Section 4, Grounding and Protection, the Semantics of Safety. You know, sometimes the most crucial updates are actually the smallest stylistic ones. Take ground fault. By definition, it's an unintentional electrical connection between an ungrounded conductor and normally non-current carrying parts. But look closely at the change for 2023. They updated the word metallic to metal. It's a really subtle shift, driven by the NEC style manual to keep everything consistent. But it just proves a point. When it comes to electrical safety, being precise with your language is just as important as being precise with your engineering.
The code also tackled impedance grounding, adding some much-needed clarity by splitting it into two distinct definitions. First, you have the impedance grounded system. That's the overall electrical system where the neutral is grounded through a designed impedance to intentionally reduce fault current. Conversely, the impedance grounded conductor is just the specific piece of wire connecting that neutral point to the impedance device. Before this update, folks out in the field were constantly confusing this specific wire with the system as a whole. Now, zero ambiguity. Finally, we arrive at Section 5, Everyday Environments, where code meets reality. Now, what's really interesting about this matrix is how the code breaks down environmental moisture levels side by side. It doesn't leave room for guessing, it strictly classifies. A damp location is an area that sees moderate moisture, like under an exterior canopy. A dry location? That might get temporarily wet, like an unfinished building still under construction, but normally it's perfectly dry. And then you have a wet location, which is subject to actual liquid saturation. Think vehicle washing bays or completely unprotected outdoor spaces. These aren't just labels. These strict definitions tell you exactly what kind of wire and enclosures you are legally allowed to use in those spots. The code even gets down to the furniture level now. The 2023 update draws a firm line between a counter or countertop versus a work surface. You might be wondering, why on earth does that matter? Well, it all comes down to typical spillage levels. I mean, you are way more likely to knock over a full pitcher of water on a kitchen counter than you are on a conference room work surface, right? This seemingly small semantic distinction is absolutely critical because it dictates the correct, safe placement of electrical receptacles in those specific spaces. And this logic scales all the way up to massive environmental hazards, too. For instance, the new definition for normal high water level helps inspectors accurately determine safe electrical datum planes near bodies of water. That is absolutely crucial for places like marinas. Along those same lines, the highly specific definitions for combustible fibers and flyings help classify hazardous environments based on the exact, literal particle size of the dust floating in the air. So as we wrap up this explainer, I want to leave you with a question to chew on. With all of these definitions now rigorously consolidated into Article 100, how are you going to approach your next site design or inspection differently? Understanding the difference between a pipe in the way, a locked door, or a Class 4 digital circuit, it all starts with the terminology.
Mastering Chapter 1 isn't just about reading a dry glossary. It is the ultimate key to unlocking and navigating the entire National Electrical Code. Thanks for hanging out and exploring this with us.